Ladies and gentlemen, welcome to this AutoSlide presentation. I'm Nithul Jalasi, and for the next 5 minutes I will be discussing about our recent paper entitled Efficient Unveiling of Multi-Members in a Social Network. This little presentation is composed of 6 parts. We start with an introduction about our work's context before presenting the problematic. Then, we introduce our formal definition of a minimal transversal multi-member, TMM, which defines the key actors in a social network. The experiments carried out on several kinds of data sets shows the interest of our approach. Our work is part of social networks analysis. The rapid growth of the Web 2.0 has increased the interest of researchers for the discovery of key actors in social networks, called, according to the authors, influencers, mediators, ambassadors or experts. In this work, we are interested in a particular type of actor in a social network that we call a multi-member, since he belongs to several communities. In this sense, we prove that detecting multi-members is similar to the problem of the determination of a subset of minimal transversals of a hypergraph. So, a social network is represented by a hypergraph, wherein vertices are the actors and hyperedges represent the communities. A new algorithm, called OM2, is introduced to extract the multi-members, TMM, from a hypergraph. So, our problematic is to identify the key actors in a social network. These actors that we want to identify correspond to the smallest subset of actors who are able to represent as best as possible the different communities. In various applications, the relations between the pairs of actors are not available. Moreover, the adjacency matrix of the graph associated to the network is not available, but the belonging of the actors to communities is known. To solve this problem in its general form, we propose to represent the communities by a hypergraph, and to define the set of multi-members as a minimal transversal which fulfills certain conditions. Interestingly, even if the extraction of minimal transversals is a NP-hard problem, it has many applications in various fields of computer science, e.g., game theory, databases, artificial intelligence, data mining, machine learning, to cite but a few. In the context of a hypergraph, where we only have communities in the network, we consider that the multi-members correspond to a set of vertices of minimum size, with at least one element in each community, and if possible with several elements within the communities of larger size. Thus, it appears that the definition of multi-members can be based on those of a minimal transversal defined as a subset of vertices, which has a non-empty intersect with each hyperedge. A set of vertices X is a TMM if X fulfills 3 conditions. First, X must be a minimal transversal. Secondly, X's size must be as small as possible, and finally, X must maximize as the recovery condition explained in more detail in the paper. During our experiments, we consider several KINFA dataset related to a management project application, datasets extracted from folk tsunamis, and a dataset worst case that we built. All the algorithms tested in our experiments produce the same result, i.e., a set of minimal transversals with a number of elements equal to the minimal level of transversality that maximizes the recovery condition. The different running times and memory consumption show that Web2D largely outperforms existing algorithms tested. In conclusion, we introduced a new efficient approach for the detection of multi-members, TMM, in a community system represented as a hypergraph. Then, we designed an optimized algorithm that directly mines the adequate level in which the TMM stand. Carried out experiments on different real-life datasets showed that our algorithm provides very interesting performances.